Again today for mathematics. So last week we discussed some fractions and percentages and estimations, approximations. So today I think I should just quickly address the issue of surds, so that we can just move away from there. A surdic expression is actually an expression of a rational number. Any number that does not have a direct square root in mathematics is a surd. S-U-R-D. So they are parts. They are not the whole set of a rational number. A rational number is more than just ordinary surds. Pi is not a surdic expression, but it's an irrational number. So irrational numbers are just simply numbers that have repeating decimals or non-terminating decimals. They can be expressed as fraction most times, but their fraction really is not the exact value. Just like pi, the 22/7 is not actually, the real value. The 22/7 is actually an approximated value of pi. So that's just by the way. So we want to concentrate on numbers that their square root will not give us a perfect value. An example is root 5. The square root of 4 will give you a perfect value, so it's a perfect square. So square root of 4 is 2.
Hello,
but
sir.
when you have square root of, I can hear you.
So can you work with your board or share your screen?
Okay, let me work with my board. Actually, I'm just trying to give a background information about it in a way. So we are talking about sorts. Okay. All right. So like I said, square root of 2, square root of 3, square root of 5, square root of 20, all this I'm writing, square root of 99, everything you have here, they are actually called surds, because this particular value, they are not exact in nature. So square root of 4 is direct, square root of 4 is equal to 2. So this is just a perfect square. So this is not an irrational number, and this is not it's just a perfect square. It's not, you can call it a surdic expression, but definitely it will eventually give you a whole number. So we really are not interested much in numbers like square root of 4, square root of 9, square root of 16, and all of that. We are only simply concerned with the numbers whose square root will not give you a perfect value. They will only give repeating decimals or non-terminating decimals, as earlier discussed. So what we want to do now is, when we have numbers like these, there are 3 things you need to know about them. Number 1 thing you need to know is simplification. You simplify them. Simplification. Number 2 things you need to know is operation in terms of addition, subtraction, multiplication, and division. Okay, so we call about operations. So they can be added, they can be subtracted, they can be multiplied, they can be divided. That's operations. And then number 3 things is when we actually talk about substitution. You can use surdic expression to substitute. And then I think at this level is where questions from JAMB actually comes in, that students are not really familiar to. Most students are familiar with simplifications, operation. This operation now, under division, is when we'll be talking about rationalization. We have single rationalization, double rationalization. Then under this substitution, I just wrote substitute. Let me write substitution. Okay, so under this substitution, we'll be talking about a special question on surd, which is called equality of surd. That is finding the square root of a surdic expression. A surdic expression has is already a number under square root. But now when you combine, an expression in surd and you are asked to find the square root of that expression, yes, so under substitution is when we will discuss about it. And then there is another thing under substitution whereby you'll be given a particular value to represent a particular surd or surdic expression, and you'll be asked to now find the expression, a new given expression in terms of the earlier given value. So possibly today, if we cannot finish it, we'll continue the next week. But we'll talk about simplification and operations to start with. It will go as a means of one, up to speed about what we need to know on simplification. Okay, so let us start with simplification. So there are numbers that, just like we are seeing on the screen now, the simplification, if I want to talk about square root of 20, okay, this number is too big to leave alone like this. I can think in terms of two simpler numbers or two lower numbers that I can multiply together. And when I'm multiplying them together, it will be in such a way that one of the numbers must be a perfect square, so as to make life easy for me. I cannot be carrying root 20 as a burden all about. There is a way I can simplify it. So when I think of numbers I can multiply, and I would do this, I can multiply 10 by 2. I will get 20. I can also multiply 20 by 1. I will still get 20. But I can also multiply 4 by 5. And I'll get 20. Now, out of all these three multiplications that I've done here now, the one that will be helpful mostly to me is this one, the one where I have 4 and 5. 10 has no direct square root, 2 has no direct square root. So 10 times 2 will still retain the value root 20. So there's no way I can go further from there. 20 has no direct square root. It's 1. So 20 times give me 20. But I need something simpler than that 20. So I can quickly think in terms of 4 and 5. Root 4 times root 5. Now I know root 4 has a direct square root. So I think it lessens the burden. The word simplification is to make it simpler. The word simplify, anytime you see the word simplify or anything that has to do with simplification, it's thinking of making it simpler. So let's go to the next board. So I want to work with square root of 4 times 5. And that is what I will use now. So in essence, square root of 20 will be equal to square root of 4 times 5. Now, this square root of 4 times 5 can be splitted up. And then I'm going to have square root of 4 multiplied by square root of 5. Now it makes it easy for me because I know square root of 4 will give me 2, and then square root of 5 remains because it will not give me a perfect square. So I will just leave it as root 5. And at the end of the day, what I will have is 2 root 5. This is made simple because definitely mathematically, when you say A times B, it will give you AB. So don't be afraid of saying 2 root 5 or 2. You don't need to put brackets because when you say A times B and you say AB means A times B. So mathematical sense would make us to leave it like that. 2 letters combined together without any operation in between simply means we are doing multiplication rather. So we have that. And then, of course, let me quickly give you an algebraic expression of this. When you have a square root and you are multiplying two numbers under the same square root, multiplication, you are allowed to split. So root A times B simply will give you root A times root B. It is allowed. It is allowed. So note that. And this is what works for us under root 20. So I can say it's root 4 times root 5, and I'll get this. So the same way we've done this, let me just take this away so that it doesn't look like directly proportional to. All right, so it will remain like this times. Now, the same way we've had this, we can work with any value in this same method, with this same method. Numbers like root 75 can be worked on, all right? Numbers like 150, numbers like 600, I can find the value of root 75. I just need to think in terms of numbers that will work for me. Now, root 75, I can do 15 times 5. 15 does not have direct square root. 5 does not have direct square root. So it may not work for me that way. I can think in terms of, let's say 25 times 3. Of course, 25 times 3 is fine and it's perfect for me. So I can use 25 and I can use 3. So this now eventually becomes root 25. Okay, let me use this, root 25 times root 3. And then what I have is 25 has a direct square root, so it's easy for me. 5 times root 3, and that gives you 5 root 3. All right, we can reverse this process. What if they don't give you something like this, and to make you break it down into a simple format like this? What if they give you in this simplified format, and they want you to get a number that has been simplified to this extent? So if they give you something like what I just put in the box now, how do you get, the Sodic expression that led to that? It's so simple. All we need to do is we reverse the process. How did we get 5? We find the square root of 25. So let me just go and get one of those example done. Before we go into operation, simplification is just breaking it down into simpler parts. So what if you are given something like 3 root 2, and they ask you to find the surds that gave you this value, that gave you this simplified expression? They can say the square root of a number yield 3 root 2. What is the number? Or anyhow, you can say 3 root 2 is equal to square root of k. Find k. Aha. So this makes sense for us. So to find k here, all you need to do is you just say 3 multiplied by root 2. Okay. So think of how you got 3 as a square root of a number. So it means you are reversing the process. Instead of finding square root now, you just square 3 and put it under square root. So we've not done anything wrong. So you just say square root of 3 square, then times square root of 2. 3 square will give you 9 times square root of 2. And then you can bring it all together under the same square root. So that's 9 times 2. So you can see that we are reversing the process we went through the other time. Of course, this one will give you square root of 18. And that makes sense for us. So it means that k must be equal to 18. That's the value we're looking for. So when they ask you to find something of that nature, so this is the value of k. K must be 18. And if you want to confirm your answer, you can follow the simplification process. Square root of 18 will give you, square root of 18 will give you square root of 9 times 2. Square root of 9 is 3. And then you have that. Give me a minute, please. Just a minute. All right, so that's what we have there. Sorry, I quickly had to attend to something. And so we have square root of 18 there. Okay, so now the next thing we want to check out is we can get as many All right, so we stopped at that. We can set as many examples as possible. Probably I can just give you some things you can work on. Probably you can work on root 600. There's nothing to fear in this. Don't be afraid whether the number is big or something. 600 is simply 100 times 6. And you know the square root of 100 is 10. So you still get 10 root 6. They are not difficult things. So you should not feel like you are doing something difficult. Root 48, all of this can be simplified. You can also work on past questions that you have with you. You will always see some things like this. Okay, so let's just quickly move on to operations. And then under operations, operation is just about bringing 2, 3, 4, 5 or more sodic expressions together with either subtraction or addition or multiplication. All right. Division is a special case that we're going to discuss. So let's talk about addition and subtraction. So if I have root 12, maybe I should just make it a topical stuff. So want to talk about operations on search, okay? Operations on search. So here we want to talk about addition and subtraction. Addition and subtraction. Subtraction. Okay, yes. So let's say you have root 12 plus root anything you can use, maybe root 24, it doesn't matter. Let me use root 12 plus root 75. Yeah, let me use this. So when you want to do this, individually, all you need to do is to simplify before you continue. So my root 12 is simply root 4 times 3. It is allowed to do that, plus root 75 has been simplified earlier as root 25 times 3. So definitely, I can just skip some irrelevant steps. Irrelevant because these are what I work with almost every time. So I know square root of 4 is 2. So I don't need to split it up separately. All right. But then let me just do that for this so that it won't look like I'm jumping steps. So I can do root 4 times root 3. Okay. Then, of course, plus root 25 times root 3. All right. So you have that. So this will now give you 2 times root 3. Okay. I'm introducing bracket to be able to make sure that I don't model things up. And as you are solving all these things, make sure that each step of the way you are tracking your movement so that if there is any reason you need to go back, you can always retrace your steps. So this will be 5 times root 3. So now this I can write 2 root 3 plus 5 root 3. Now, at this point, this is a very interesting thing. 2 root 3 plus 5 root 3. If you like, you can go by means of factorization. Fine. And if you like, of course, it is direct for me. It's like I say 2 oranges plus 5 oranges. Because root 3 and root 3 are the same variable, I can add up. They are like terms. So this, I will have 7 root 3. All right. So this is my answer for addition. That's my answer for addition. 7 root 3. Yes. 7 root 3. You get this as an answer. What if it is subtraction? It's still the same thing. But what I want to tell you is that it is not in every cases that you have root 3, root 3. If they are of different roots, you should not add them. It's like when you say 3 chairs plus 2 tables, you cannot get 5 chairs because a table cannot transform into a chair. All right? 3 chairs plus 2 tables will remain 3 chairs plus 2 tables. There's no way you can add chair and table together like that, unless you want to give it another name. 3 chairs will remain 3 chairs, 2 tables will remain 2 tables. So when you say 3 chairs plus 2 tables, you will still get 3 chairs plus 2 tables. So let me give you an example in that sense. Let's check this out. So if I have root 36, I think this is nice enough. Plus, I'm just using one simple question, plus root, let me use root 50. Let me use root 50. I will use root 50 here. Okay, it's not 56, so it's 50. Because I don't want anybody to misinterpret mine. And thank God this is recording both texts, images, and the voice. So you'll be able to grasp everything. Now, root 36 plus root 50, I'm going to be quick with this. No, let me not use root 36. That's a perfect square. Let me use root 8. Root 8, yeah. Let me use root 8. Root 8, root 8, root 8. Do I want to use root? No, I don't want root 8. Let me use root 32. Yeah, I just want something, even 32 will not work for me. I don't want, okay. Okay, let me use root 72. Yes, this works now. Even 72, I don't want. I'm just looking for something more interesting. Root 98. Okay, let me use root 98. Let me use this. Then plus root 50, now plus root 27. Aha, I think I like this. So 3 things added together, this is fine. No, in mathematics, when you play around it will give you opportunity to play around number with relative ease. So we have this question we want to solve now. Let me come again with it. I'm okay with this one. Root 98 plus root 50 plus root 27. So when you have all these 3 and you want to add them together, how do you add? Let's go. Now, root 98 will be root. You have to think fast, because don't forget, the exam you are having, 50 questions in how many minutes? So you have to be very fast with the way you think. How will you break down root 98? Root 98, you can use 2 times 49. Of course, that works for me. 2 times 49, because square root of 49 is 7. So I'll write 49 times 2 plus square root of 50 will give me 25 times 2. And then now for square root of 27, that will be, what can I multiply? Of course, nothing else but 9 times 3. So you have all of this. Square root of 49 can be found, so I will just compress it now. 7 root 2 plus 5 root 2 plus 3 root 3. Yes, that is what I will have. 3 because square root of 9 is 3, square root of 25 is 5, square root of 49 is 7. So at the end of the day, 7 root 2 and 5 root 2 can be added. This one, they are of the same type. It's like 7 of this plus 5 of this. Of course, you get 12 root 2, 12 root 2 plus 3 root 3. This is the exact example I'm telling you about. There is no further simplification to this. It's like 12 chairs plus 3 tables. You don't add anything beyond this. You have to leave it this way. So this is what you can get here. Let's talk about, in the next, I think 5 to 10 minutes, I guess. Host, do we still have up to 10 minutes? I think we should. So let's just quickly move on. So we have, yes, sir. We have this example to work with, square root of 60. Let me use 60 minus square root of, let me use square root of 450. Anyhow, yeah, let me use square root of 450. Anyone there, plus maybe square root of 300. Yeah, I'm trying to combine several things together now. When you have something like this, So what do you do? To break this down is not too difficult, of course, it isn't. 60, we have to think, what and what can 60 give us? The ones that have direct square root and the one that does not have direct square root. I can think of 4 and 15. I can think of 4 and 15. When you say 12 times 5, you will still be right. But at the end of the day, you will still break 12 down to 4 times 3. 4 times 3 times 5. So you still have 4 times 15. So don't let us stress ourselves out of that. So what I'm going to have is square root of 4 times 15, then minus, this one is a very interesting one, square root of 450. What can we do? Square root of 450. We can just say 15 times, what would that be now? That would be 15 times 30. Yeah, I think. Yeah, 30 times 15 will work. 15 times 15, no, 225 times 2. Yeah, it works. So I have 225 times 2, then plus square root of 300, that is 100 times 3. Yeah. So I'm going to write this on the next board. Let me repeat it. 4 times 15, 225 times 2, and then 100 times 3. So that is what I have. 4 times 15, 225 times 2, and then 100 times 3. So let's move on. So this one will now give us square root of 4 times 15 plus square root of 225 times 2 minus square root of 100 times 3. Okay, so we know what to do here. Square root of 4 is 2, so I can do 2 root 15 plus square root of 225 is 15, 15 root 2, then minus 10 root 3. That's it. That's all you can see root 15 and root 2 are not the same, and root 10 is not the same. Okay. Even if you say you want to factorize, there is no common factor. 2, 15, and 10 are whole numbers, but yet there is no common factor between the three of them. So I think it's better we leave our answer in this format. You might be lucky to have the ones that will have a common factor. It's fine for you. Let me quickly introduce you to the concept of multiplication, so that we'll just know that what we have left is the substitution and the rationalization, which is division, actually, rationalization. Now, in this case, for multiplication, it's the same thing. But one thing you need to know about multiplication is this. Let me give you the algebra of it. For multiplication, we say a root a times root b, we have established this before, is equal to square root of ab. All right. Then root a times root a is equal to square root of a square. And when you have a square, square will cancel square root. So this one will cancel this one. So what you have left is what? A. I want you to note this. Root a times root a will always give you a for any number. Once it is the same number under the square root and you are multiplying them together, it will give you the exact number. So root 10 times root 10 will not give me any other thing than 10, because it is 10 square under square root. So when you say square root of 100, you still get 10. So note that root a times root a will always give you a. It's a very important thing that most students always fall into, a very simple error that they will always misinterpret it. But please, I want you to note that. So if I have root 2 into 3 maybe plus root 5, this is multiplication just by expansion of brackets. Okay, root 2 times into bracket 3 plus root 5. Of course, it is distributive. Just open the bracket and be fine with whatever you have. That will give you 3 root 2 plus root 10. Why root 10? Because root 2 times root 5 is root 2 times 5, which is 10. So you have something like this. All right. So I can from here go into some other complex examples. Let's check the next page, but let me leave it here for the next 30 seconds. If anybody has any question, you are free to ask. If you have a question, please be free to ask. If you have a question, be free to ask. And I want to still believe you are looking at. So I want to take it back so that we can move on to the next one. All right. Let's go to the next one. So if I have, there may be a situation where you have something like 5 root 2 plus 3 root 3 into bracket. For the sake of space is why I'm not writing on the same line, but it's the same thing. 2 root 3 plus maybe, or let me use minus. It doesn't matter anyhow. Let me just still retain the plus. It's expansion, basically expansion that you are used to, all right? 4 root 2. So don't be afraid when you see questions like this. It's simply you are multiplying the first bracket by the second bracket. And by what you already know, one thing I would just encourage you to do is please pay attention very well. Whenever you are multiplying, numbers can only multiply numbers, and then roots can only multiply roots, okay? So whichever way you choose to expand your bracket, either that you want to expand it separately, just like I did the last one, I can put 5 root 2 outside the bracket to expand 2 root 3 plus 4 root 2, then plus 3 root 3 into bracket 2 root 3 plus 4 root 2. Okay, I can do it like this. And I can also use another expansion, which will of course give us the same answer. Let's just go by this one. 5 root 2 times 2 root 3. You multiply the number separately, you multiply the bracket separately, I mean the surds separately. So at the end of the day, what you get here is 10 root 6. It will give you 10 root 6 plus what you are going to have is, I will have loved to ask question from here. What do you think I'll have next? 5 root 2 times 4 root 2. 5 times 4 is 20. But root 2 times root 2 will give you 2. So everything now ends up being a number. That's one thing I want you to know here. So it will be plus, because you'll be wondering, how did I get what I got? So let me use this. We've done this. How do I place it now? Root 2 is multiplying root 3. 5 is multiplying 2. That was how I got 10 root 6. But this time around, I am interested in the next one. Root 2 is multiplying root 2. 5 is multiplying 4. So what I will now have is 20 times 2, and that will give you 40. All right? 5 times 4 is 20. Root 2 times root 2 is 2. So plus, let's go for the next one. Root 3 times root 3 here too. The same way, we are going to also get root 3 is multiplying root 3. 3 is multiplying 2. So this will have been 6 times 3. So what I'm going to have here is 6 times 3. All right? Now, plus this next one, 3 is multiplying 4, that's 12. Then root 3 is multiplying root 2, that's root 6. So this is how the multiplication is based on the explanation I gave earlier. Okay, I want to round up this class in the next 2 minutes. So I want you to pay attention to all the lines I draw to show why the terms that I wrote in red will never give you anything that has square root based on the instruction I gave earlier. So our final answer will now become 10 root 6 plus 40 plus 18 plus 12 root 6. And you can see that we can still add 10 root 6 and 12 root 6. 40 plus 18 is 58. So we have 58 plus 22 root 6. This is the result of the expansion. This is the result of the expansion. And I'm going to stop here on multiplication. So far, we've explained the concept of sort. We've talked about addition. No, first we talked about simplification. After simplification, we mentioned addition and subtraction, and now we are on multiplication. So those are the ones we've been able to do so far. And I want you to try some simple example I said earlier. I'm going to give you questions that you can practice. Probably just let me leave you to practice from your past question and answer, because I want you to be more focused on the kind of peculiar question that will be coming. So it won't look like I'm giving you something outside the syllabus. So look for questions and answer on sorts, and then solve. If you cannot get them solved, you can send them in. Based on all that we've explained so far, we'll talk about it. So next class, we are going to continue from rationalization of sorts. We are going to talk about rationalization of sort. There is single rationalization, double rationalization, and double rationalization will lead us to the concept of conjugacy. We talk about conjugate sorts, and after that, we'll now talk about substitution in sorts and then equality of sorts. If time permits, I think we should be able to get that done next class, so that it won't have to extend unnecessarily to more classes. But if there are more clarification you want, we can also work on that. So I think with this few points of mine, I don't know why I should call it few points. It's okay, but then sorts is a very simple mathematical topic, which I believe if you go through this lesson, you won't have problem